Today I want to talk about my agentic workflow. Actually, before I start with the workflow, I wanted to give a shout out to Antonio and Alexandru, who spent time watching my last video and gave me thoughtful comments. They had absolutely no reason to give me time or to be nice to me, but they chose to. So thank you. So coming back to my agentic workflow, actually, before we get into my workflow, I want to talk about what I think is the difference between a harness and a workflow. For me, a harness is like a law of nature. It sets the laws of nature that the agent cannot break. The agent cannot break these rules. While on the other hand, workflows are man-made rules. Say, for example, there's a speed limit of 50. I can choose to break the speed limit. Of course, I'll have consequences later, but I can choose to break the speed limit. So that's what I think a workflow is. It also sets rules, but these are suggestive rules. These are not the laws of nature. Okay, so now that we are clear on what a workflow is, I want to talk about what are my goals with even like creating a workflow. Remember, I'm a broke indie dev, okay, and I only have $20 to spend on ChatGPT, and with ChatGPT comes Codex, so I use Codex, and my agentic workflow should make sure that I'm able to optimize my tokens and also maximize my task completion. So these are my goals for my workflow. And to achieve these goals, my workflow is divided into 3 key modules. A module is just like smaller parts of my workflow which have goals of their own. So each of these three modules have their own goals. So let's actually get into these 3 modules. So the first module is intent routing, the second module is atomic task graphs, and the third one is knowledge indexing. So the first one is more of a convenience module. It's just easy. It makes life easier for me. But module number 2 and 3, which is the atomic task graph and the knowledge indexing, actually help with optimizing tokens and maximizing task completion. So let's start with intent routing. As the name suggests, intent routing is nothing but like a general agent which talks to me. This is me. It figures out what I want and then assumes the role of the agent that I actually need to talk to. In my case, I have 4 agentic roles. One is a manager. A manager is an agent that can spawn worker agents. And these worker agents do tasks. I can't directly access worker agents because these are not like a user-facing agent, but the manager is. So my router agent, or like a general agent, routes me to the manager, or it can route me to the feedback receiver. So this is an agent that receives feedback for me and then creates tasks for like future feedback resolvers to resolve. Or it can be like a feedback resolver. So this is again an agent that resolves my feedback, that the agent created with the feedback created by the feedback receiver is resolved by the feedback resolver. And the 4th agent is more of a init agent. Init agent is nothing but a setup agent. So say, for example, I'm setting up my workflow for the first time in a new repo. My routing agent should route me to this specific agent. And when I say routing, these are not different agents. This is just a general agent at first. Once it understands my intent, it assumes the role of either the manager, the feedback collector, feedback resolver, or the init, or the work or the setup agent. So that is intent routing, and this is just for this just makes life easier for me when I'm working. Okay, so this, now that we understand what a intent router is, let's move to the next one. I love erasing with this. This is so cool. Okay, the next one is atomic task graph. To understand this, let's first discuss what an atomic task is. In my opinion, an atomic task is the smallest sized task that gives you a high probability of success when an agent is working on that task. Say, for example, there's a task, add 1 plus 1. Okay, and if I give an agent this task 1,000 times, I would hope the agent at least gets it right 999 times. So I would call this an atomic task, because this gives us a very high probability of success when an agent takes up this task. And whenever there are like these big tasks, say for example, I'm building an application, I want to be able to break down this big task into atomic tasks. That means tasks that have a high probability of success for the agent. So I want to be breaking them down. And the next thing, as far as atomic task goes, is having a boundary around the task. Say for example, this is a tiny atomic task given to the worker agent. And by the way, tasks are done by the worker agents, which are in turn managed by the manager agent in this system. And the boundary given to the worker agent is these other pieces of the repo that it would need to understand to be able to complete this task that it is working on. This is the task it is working on, and it needs a knowledge of all the rest of the builds around that specific task. And this boundary is given by the manager. Again, this is a suggestive boundary, so the agent working on this task can always break the boundary. In most cases, the information or the modules that this specific agent can access are good enough for it to like do the task. But in some cases, it needs to go up the hierarchy. It needs to go to like some component that has nothing to do with this. It's like higher up, because it is directly connected to this one. So it needs to understand some random component up there to be able to finish this task. So in that case, it's still suggestive, so it can break that boundary and do that task. By the end of the day, the worker still goes and reports to the manager. So if the manager thinks, hey, the worker has gone out of its bounds and it shouldn't have done this task using this, then it can always revert. It can always say, okay, your work is not valid anymore, and it can restart this worker agent or reassign a different worker agent to the same task. Or it can say, hey, this is okay, what you did is totally fine, and it can approve it. And all of the tasks have commits to them, as in after a specific task is completed, there is always a commit made. So there are always save points that I can go back to. So those are atomic tasks, and this is the task boundary that we just discussed. And lastly is the graph. So when there are multiple tasks, there are different tasks that depend on each other. Say for example, the very first task T1 is the base level task that needs to be done for tasks 2, 3 and 4 to open up. So a task graph is drawn. So once 4 is done, maybe 5 and 6 open up. So this is a task graph. 2, 3 and 4 are dependent on 1. 5 and 6 are dependent on 4, and something else might be dependent on them, and like the whole task graph goes down like that. And whenever there are, say for example, in this case, 2, 3 and 4 are parallel tasks. So if I just complete this task 1, 2, 3 and 4 can be done in parallel. My manager can put 3 different workers that can work on these 3 guys in parallel. But for all of this to be managed, you need the atomic task graph. This is another optimization module, task and token optimization module for me. So that is the second module. And by the way, these things people might already be using these things. I'm not claiming that I have like invented them or anything, but these are just things that I use. And coming to the last module, it is the knowledge indexing. And just as the name suggests, it is just indexing. And this is specifically a token optimizing module. So whenever I initiate like a manager or some agent, I don't want it to read my whole repo because that's a lot of tokens. I want it to know what it can read. And that is where indexing comes in. Index is pretty simple, right? So I have like a whole application, and my application is divided into different modules. And then there is a small little index right here that says, hey, if you want to work with this module, this is where it is. It gives the path. If you want to work with this is where this is. This is very similar to, say, there's a book and then you have chapters in the book, right? And then there's an index. Chapter 1 does this. Chapter 2 is about this. Chapter 3 is about this. So my agent can directly go to the index, read through all the index and say, hey, I just need to read chapter 2 and chapter 3. I don't need to touch chapter 1. So the tokens for chapter 1 have been saved, which otherwise it would have gone and read. So this is knowledge indexing. Although there is a small problem that comes with knowledge indexing. Every time you complete a task, your knowledge indexing should be updated. If your knowledge index is stale, then all the agents that come after will keep indexing the stale knowledge, and they'll keep making mistakes over and over again. And instead of like token optimizing, you'll be losing tokens. So as a part of my workflow, after every task, it is mandatory for my agents to go and update the task index and then to make a commit. So that's how I set up my agentic workflow. And like I said, my whole objective is to minimize burning tokens and maximize task completion. So the whole workflow is open source. It is just out here. I'll share this link with you guys in the description. And the way I would use this, say for example, this repo is right there and I am starting to build a new application. What I would do is I would clone this repo, or I'd just like copy everything inside this repo and I'll put it in my new repo and in the root of my new repo, and then from there I'll start. By the way, start.txt is like my intent router. So this gives all the information for a specific generalized agent, and it gives the information for it to assume a specific role. And from there on, there are multiple agent starters. So it directs it to whichever agent starter it needs to go to. And then there are a bunch of things. You can always read through the rest of it if you want. And you can start with reading the README. So you'll understand what this is all about. And also, this is not like a end all and be all kind of workflow. You should be able to like update it based on what you want and stuff like that. This is just one person's workflow. This is just what works for me, and even for me this will be updating and this will be evolving, and I expect the same from you. So please feel free to check it out, use it if it is useful for you. If not, that's also fine. And in the next video we'll be talking about, we'll actually be using this workflow and start building cohort. I've already started building a little bit, but we'll keep continuing building until we get to the end. All right, I'll see you guys.